everybody. It's your favorite teacher, Mr. Dywert, back with your second lesson of geometry. So, with this part, we're going to start with the 14th term, angle bisector. So this is whenever you have an angle that is split exactly into by a line. So you have A, B, C, D. So whenever BD bisects ABC, that is an angle bisector. Also, point D right here is equidistant to point C here and point A here. So that is an angle bisector. Next, we have the segment bisector. This is whenever a segment is cut exactly in half by a line or another segment. So it can come in from multiple directions, say from here, and it comes in from here. That is an example of a segment bisector. It can come from many angles, but it splits this right here in half. So say this is 10 right here, this right here would be 5. This segment bisector can also come in from the middle or from the opposite direction. So that is a segment bisector. Next, we have the perimeter. The perimeter is the measurement of the distance on the outside edges of a shape. So say we have 6 by 4. So to get the distance around, you want to do 6 times 2 plus 4 times 2. And then you get the perimeter, which would be 20. There you have it. So that is perimeter. Also, when you're working with perimeter on different shapes, say pentagon, say it's a perfect pentagon. So 5, just multiply that by 5 to get 25 as your perimeter. Triangle, say it's a regular triangle. And 6, multiply by that 3, and then you'll get 18 as your perimeter. And then, however, a circle, you have to go by the radius. So 3 is the radius, and then the formula for that would be 2 times pi times 3. Next we have the area, which is the amount of space inside of a closed 2D object. So see the area of this square right here, so 4 by 4. So then you multiply 4 by 4 to get the area, which would be 16. And there you have your area. And now we have the convex. A convex is any polygon, say hexagon, octagon, square, triangle. These are all polygons where the vertices are pointing to the outside, and all the angles, each interior angle will have a degree of less than 180. However, you have the concave. This is any polygon, say kind of like the shape of Decatur County. So a 7-sided figure right here. However, it'll have a vertice that points inward. So the vertice is pointing in. And this vertice will have an angle greater than 180. And now we have parallel lines. Parallel lines are lines with the same slope and they also never touch. And it can be sets of 2, 3, 4, 5, 6. They may start from different points, but they're always parallel because they have the same slope. And now there is the perpendicular line. Unlike the parallel line, they have opposite slopes, so they cross. Another thing, they make a 90-degree angle. So right here you see a 90-degree angle from this cross. And it can be more than one. So here's another, right here, another perpendicular. It can be sets of multiple perpendicular lines. And now you have the skew line. Unlike the parallel or perpendicular lines, this would be based on a completely different plane. So say you have one plane here, and a plane here. Because normally, this is based on a three-dimensional plane rather than two-dimensional flat planes. You have three-dimensional shapes. So the lines, even if they seem to be perpendicular, because they could be like this and this, perpendicular, they're not actually perpendicular because they are on different planes. And that would go the same with parallel. Next, we have alternate interior angles. Say you have a transversal. Alternate interior angles would be like this angle right here and this angle right here. They have the same measurement, but they're on the opposite sides of the inside of the transversal. So this is 60 and this is 60. Here you have the alternate interior angle. Next is the alternate exterior angle. So it would be angles on the outsides of the transversal that have the same measurement of the angle. So this right here and this right here. They're on opposite sides of the outside and they have the same measurement. So this has 120 degrees and so does this one. So there you have alternate exterior angles. And then you have same side interior angles. These angles are always supplementary because they're on the same line. So say you have an angle that measured out to 120 and then this one measured out to 60. They're on the same line, same side, and they're supplementary. That is the same side interior angle. And finally, you have the the corresponding angles, which they are on a transversal and they're one right after the other. So 60 and 60. They have the same measure of an angle and they're on the same line and they follow one after the other. You can have it here also with the 120s. So that is the end of the lesson, and thank you for watching. And you interrupted at the end. Good job.